All right, we're actually ready to start doing writing of the code here, but there is one thing that we need to correct here, and it has to do with something I said in the videos previously. Um, that when we're doing this here, we can see this. I said not LCD blink on, and that would mean that I should be turning the blink off. That's not incorrect, but I'm using the wrong not. Um, because what we're saying here is that if I do not LCD blink on, that this is what I'd be getting. But actually, um, what you end up getting when you do that negation is actually simply just this. Because that's literally just saying, oh, I've got a binary 1. What's the opposite of binary 1? It's 0. Um, and then it would say, well, if you did it again, what's the opposite of 0? It's 1. It's looking at binary when you do that pound or exclamation point, not pound. What we want to do is we want to do bitwise. We want bitwise negation. And so we can do that. Instead of using the exclamation point, we use the tilde. So if we use the tilde, then we get the 111, 1110. So obviously that's critical. We need to use the tilde for our knots and not the exclamation point. So again, this line would then be, it's still a knot, but it's the tilde. And then my De Morgan's explanation is still correct. It's just we have to be careful when we're talking about bitwise operation versus variable, like versus a Boolean 1 or 0 kind of thing. And the exclamation point is a Boolean operator, not a bitwise operator. So we have to do the tilde for the not commands when we're doing these bitwise operations. There is one other thing here that I want to correct here for us when it was saying here, when we were saying display control here, D4, D5, D6, D7, and then we said, oh, this is 0, enable RW reset, and then I had ones here for some reason. Oh, this was actually the function here. This is actually incorrect here. That 0, when we write to a device here, that is not going to be a 0 there. That actually is backlight. The LCD screens, and I did this by trial and error because the data sheet, well, quite frankly, there's no data sheet for the LCD screen itself, and the data sheets don't have anything about the backlight. The backlight is something that's been added independent of all of the other devices. So, it's not part of the chips that are on there that are making our circuit run. So we have to make that correction as well, that's the backlight there. And so when we want the backlight on, which is what we're going to want, you're going to want the backlight on. If it's off, the screen is really dark and it's really hard to read. So we're going to want the backlight on, actually. And so we're actually going to always want this to be a 1, because that turns the backlight on. So when we're writing, because we talked about how we're going to have to split a byte of data into 2 nibbles that we write, part of that nibble, the least significant 4 bits, it's always going to be 1, and then the enable, read, write, and register select bits will be set depending on what we need them to be. Okay? So I wanted to make those few corrections here before we start diving into code. Now what I did here, and I'm going to just kind of pause here, and then I suggest that you pause the videos as well, is, well, let me maybe go to my top design. So just to make sure, I've put in an I2C master in here. That's the only thing, and of course, I just let the pins get auto-signed here. I mean, that's where they have to go. And then I generated the API, so I have all the APIs now ready for me. In my main function, I actually had written some code here for some testing purposes, but you'll notice that I already started the I2C in my main code, and I already have some of the project files included. But what I want to do is go back to this header file, and I'll talk through it, but I'm not going to sit here and write every single thing out. So we have a lot of macros defined here, and then I've even kind of got through here and defined even some other macros here. So first off, these are the commands currently that I have set as far as macros go. And where did I get these numbers? Well, I got them here for command clear display. I mean, it's right here, clear display, and it's just 1. I mean, because I'm looking at what is these 8 bits give me as far as a number goes, and that would just be simply 1. And then if I go to the next one, we can see return home. Again, it's just a 1. Now for entry mode set, this is where we're going to have both a command and bit masks, because the command to do entry mode set is having a 1 on the 3rd bit, or DB2. That's what gives the command for entry mode set, and then these are kind of the options. So these are the bit masks that we will be setting. And so if I go back here, what I can see here is that, well, entry mode set, that was in the 3rd position, so the command is 0x04. And then continuing on, we can see here that I have display on off control, and that is 8, which is again right here. Now you'll notice that I don't have here, or actually no, I'm sorry, I do have it, display shift here, which is now DB4, so that's 1, and I'm not putting in, again, these bit masks here. And then I have display shift as 10, function set as 20. Now there are some other commands that I didn't put in, which depending on what we do for these projects with the LCD screen, you might be putting these in here. So there's a set C gram address, that's character, and set D gram address, that's data. And so, you know, we might be using these commands later on, but I haven't put them in the API at this point. Now the other thing we should notice here is the execution time. First off, notice that return home has got an execution time of 1.52 milliseconds. That's important because we're going to want to delay, once we issue a command, we're going to want to delay enough time to make sure that that command has been executed. Then everything else is 37 microseconds. Except, I mean, obviously there's one here that's 0 microseconds. Okay, so that's where all my commands came from. Then the bit masks, how did I get all these bit masks? Well, again, I'm going back to the data sheet, and you might want to just, again, pause this at some point and just type all of these things in here. I kind of grouped them together and even gave them names associated with the command. So when we're having the entry mode set, I said LCD entry increment as 0x01. So now let's go to the data sheet here and see how we have that. So if I look at this, this is ID, so that's increment. It's either increment or decrement, and I actually might have an error there. I do, because increment is 1, that gives me an increment. 0 is decrement. So I'm not going to actually put in a decrement because decrement is just the opposite of increment. But what I did wrong here is notice where the increment is. It's in bit position 2, DB1. So that's not corresponding to 1. That's a 2 there that we should have. And then if we do LCD entry shift, that's this one here, which is definitely going to be a 0 or a 1. And if we go down here, S equals 1 accompanies display shift. So basically what that means is that's if we're going to be doing this cursor display to shift. You know, so we have that being a 1 or a 0. And again, I only included the 1 case because if we want to turn it off, we just negate this to turn it off. And now I go down and do the same thing for the cursor for the display command. If I have the display command, if I go back up here, there's a D, C, and a B. Okay, sets entire display on, off, cursor on, off, and blinking of the cursor position on or off. Now, if you notice here, in these here, it doesn't actually give us that information. So what you do is you continue reading through the data sheet, and you can say, okay, well, display on-off control. Oh, okay, well, here it is. The display is on when D is 1, off when D is 0. Okay, cursor's displayed when C is 1, and it's not displayed when C is 0. And then there's a blink for 1, and it says figure 13. I don't know what that is about, but you could look at it. And 0 if it's not blinking. So if I go back up here, if I want the screen on, this would be a 1, which given its position would correspond to 4. Cursor on would correspond to 2. Blink on would correspond to 1. So if I go back here, display on is 4, cursor on is 2, blink on is 1. And then again, to negate those, if I want to turn the display off, I'm not going to write one for display off a macro. I just would basically negate the display on, because if I want it off, I'm going to do the opposite of turning it on. And now you can go through and see the rest of these. I'm not going to go through them, but you can look at the data sheet to see the rest of them. Now, this right here, these 4, you won't find them on any of the data sheets. This is basically almost, in some ways, trial and error and just knowing how the device is wired up. So remember that I2C device here. Let me pull the data sheet back up for the I2C one here. What was that? PMS. Was it 8916? No. Am I even doing the wrong? These are power converters here. Let me see if I can just find it real quickly on Amazon in the video or in the product here by looking at the picture there. PCF. There we go. So if we look at this data sheet again here, basically there are 8 things coming out of this, but what we have here is we have to be in 4-bit mode for this, because these 4 bits here are my data. This is like the D7, D6, D5, D4, and then D3, D2, D1, and D0, because we're splitting a byte into nibbles. This one is connected up to the backlight that we talked about at the beginning of this video. So that's a 1 or a 0 to turn your backlight on or off. So we're typically don't want that as an on. Then this is actually wired to, and again, this is somewhat trial and error. This is wired to the enable on the chip here. So if we go back to the chip itself and go up to the pin diagram for this chip, we can see that there's an enable right down here. Well, I don't know if this is the footprint that's actually being used, but the idea is here, pin 38 is the enable. And so that is what's connected to pin 2 here. Pin 1 is connected to the read-write, which is pin 37, and then the register select is connected to pin 0. So that's the reason we actually have to have it in 4-bit mode, is because of the way this is connected. Now, as I said, the frustrating thing about this is there was no data sheet that explained this. It's kind of hunting on the internet for information, going to user groups, forums, and then some trial and error on my own part. The trial and error is how I figured out the P3 controls the backlight. So that's where all of these come from here. The LCD enable is 4. LCD read would be having a 1 on there, which would be 2, and then the LCD putting a 1 on the register select is 0. Now, I put this here, LCD, this stands for register select 0 in write mode as 0x00. The reason I added this macro is this is what we're going to be doing most of the time. So as opposed to always negating these things, because that's what we'd have to do, I just simply said, hey, this is what we're going to do most of the time. And how do I know that's what we're going to do most of the time? Again, I looked at the data sheet here. Let me go back down. I know I scroll up and down this data sheet a lot. I apologize for that, but let me go back down this data sheet. You might want to even just print this data sheet out. So if you look here, all of these commands have register select and the read write being 0. They're both 0. 0. The only time it's not 0 is if we're wanting to somehow read the busy flag and address. Then we have the read write. Well, register select is still 0, but the read write is 1. Now, writing data to the CG or DRAM, that's when we have a 1, 0 here to write data. And then there is one case where we have a 1, 1. Now, we probably aren't going to even actually use these commands, because as I said, there's a lot you can do with this. Like, you can create custom characters for this device. Like, you can create your own unique fonts and everything for it. So we're probably not going to do that, but there's all sorts of things. So that's where, on my code here, that's where these things came from. And again, since I'm going to be doing this primarily, that's why I put it at 0, 0. Then the LCD backlight, in order to have it turned on, is 0, 8. Because again, if we go back here, this is connected. We said this is the backlight, so this would be 0, 2, 4, 8. So turning the backlight on means I'm going to need to have that be an 8. All right. So a lot of explanations on just the macros. So we did a lot of stuff on the macros. Now here, let's look at some of these functions here that I have here. So first off, I have an initialize function, and this is where we can input what the address of the component is. And I put that there because, even though for the one that I've been using at home, I know the address is 27. Remember that chip that we have, that I2C chip that we're using here, has the ability to have up to 8 different addresses. So I want to be able to have the ability to change what that address is. I don't want to have to force someone to say, well, if you don't have the one that has 0x27, screw you, you're out of luck. I want to make sure that they can tell me whatever the address is, because there are models that even have a slightly different chip in this, and it's the PCF 547 TD, maybe? Let's look at this one here. I'm looking for the data sheet on this. Not technical data sheet. And so, you have the ability to control the address on this as well. But yeah, see here, what's fixed here is 0, 0, 1, 0. So this would be 0, 2, I'm sorry, 0, 1. Oh, this is still 2. Oh, here it is, the A here. Look what the fixed is for this one. 1, 1, 1. If you have the PCF 8574A, the fixed portions for the address are, okay, well, it's 1, 1, 1, which would be, what, 3, 7. So that's the reason we want to be able to have the ability to have the user be able to change what the address is. The difference with the MPL 115A2, there was physically no way to change what the address was. The only way to change that address would have been to contact the manufacturer and see if we could get a different address, I2C address for that sensor. That was fixed. But because we're using this I2C device that has a programmable address, which a lot of I2C devices have programmable addresses, because of the fact that we don't want to have 2 sensors that have the same address on the I2C bus. They always have to have different addresses. So this is probably going to be something that we do in most of our APIs for I2C. And then we're also going to put in, okay, well, how many columns does this does this LCD display have? How many rows? And then the character size. The character size is going to be a 0 or a 1, and that really just is going to determine whether it's, it's actually right here, 5 by 10 or 5 by 8. And you might say 0, 1 here, you got a 4 here, but we'll have an if statement that basically says, well, if it's a 0, that's a 5 by 8, which is the default. If it's a 1, then it's 5 by 10. And again, 5 by 10 is only for some very special one-line displays. Then, of course, we have to start it up, and we're going to have to start it in the 4-bit mode, which we're going to do in the videos here. And then I have some functions here that we're going to write together. There's going to be some additional functions you have to add, which will be part of your assignment. And these obviously are pretty obvious ones. Okay, turn the display on and off, turn the cursor on and off, blink on or off, set cursor, so you can set it in a particular column or row position. That's useful. And then LCD print, and basically a string, so we can print something to it. Actually, there's going to be 2 others that we'll add here that I just thought of, that we'll go ahead and add. They'll be very easy. Actually, I'll just put them after here. Void LCD clear, void, and then void LCD home, void. So that will just let us clear the display, and home basically sets the cursor. And you want to think of it as in the row 0, column 0, because that's how we need to think about this as far as where the rows and things are. So then let's look at this next file here. This is just the C file. All I've done is outlined and put all the functions down in here as well. So let me go ahead and add in the 2 that we just decided to create. And so these are all the functions that we had. These are just literally from the H file. Now there's 2 internal functions here, because remember, when we say write byte, we're not going to be able to just simply write byte using the write byte from the I2C, because remember, if we're writing a byte of data to the LCD screen, we have to split it into 2 nibbles and then write each nibble. So I'm going to have an LCD write byte, and in that I'm going to split it into nibbles. And this mode here is, what mode do we need to be? Is it LCD RS0 write? Is it LCD RS, LCD read, LCD enable? That's what we need by the mode. And so the mode is, when I think about it, going back to the data sheets here, I'm using mode as defining what these values should be. And now you said, yeah, typically it's always going to be 0, 0, but there are some cases where it's not. So we have to make sure to account for those. So that's why we want to try and write as robust of a set of code as possible. And then we have basically the write byte is going to split it into nibbles, combine the nibbles together so that we get, the first 4 bits of our byte that we're writing is going to be the most significant bits, and it's going to be the nibble portion. And then the second one's going to be the backlight, and then the register select, the read write, and then also the enable. And so we're going to have a function that writes nibble. Now inside this function for writing a nibble, we will absolutely have I2C master write bytes commands. All right. Now, the other thing we need is we're going to have some global variables, because we're going to want to have things stored for us all the time. And I didn't write them all lowercase like I typically do, so I'm going to actually change that, because I like using all lowercase for global variables. LCD. And the reason I have these as global variables, let's just think of a few reasons why I would do this. First off, knowing what the character size is important. Of course, knowing the actual address of the device is important, because I'm going to be passing that all throughout the programs. Now I'm going to need that in various write functions, what the I2C address is. But then this entry mode display, display shift, and function set. Well, what is that? That goes back to this entry mode, display, display shift, and function set. It goes back to those commands. In other words, this is going to be containing essentially what the last command was that you executed for a display shift or a display. It's going to contain the last command with the bit shifting masks on it, with the bit masks on it. So this, we'll initialize this in essence. So we'll initialize LCD display, for instance, and we'll probably initialize it, to have the screen on, the cursor on, but maybe blink off. Maybe that's what we're going to decide as an initialization. That's just the default of how it's turned on. So we want to store that, though, so that if we want to, for instance, just turn the cursor off, we can not have to worry about keeping the screen on or whether the blink's on or off. We can just use that and update that global variable every time we want to make a small change to it. So that's why we have those. And if we go back to the C program here, oh, I didn't put them at the top yet. Well, I'll do that here. So I'm actually going to end the video here. So let me go ahead. I'm going to scroll back up, pause for a second on each of these so you can get a good screen here. So I'm going to count to 5. You can mute me or something. 1, 2, 3, 4, 5. Now I'm going to scroll down. 1. Here, let me get this. 1, 2, 3, 4, 5. And then finally, 1, 2, 3, 4, 5. I'm going to do the same thing here. This is purely so that you can make sure to have your code matching mine. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. So now you should be able to pause the videos and get everything typed in. The only thing that we should add, and we'll do it in the next video, at least for one of them, is headers for all of these functions.